lesson 3.1, students see copper and aluminum cubes on a balance. They're exactly the same size and shape, so they're the same volume, but the copper weighs more than the aluminum. And the question is why? What is it about the copper that makes it heavier? We're going to eventually try to get to the idea of density, that if they have the same size and the same shape, and therefore they have the same volume, and one is heavier than the other, that one must be more dense. But the question is, what makes it more dense? So we're going to try to get kids to understand that it has to do with the atoms that make up the copper and the aluminum. And if the copper is more dense, it must have something to do with the mass of the copper atoms, or their arrangement, or their size. And we'll eventually try to get to the idea of density, and that density is a characteristic property of a substance. So let's see. When you begin to analyze why it is that copper is more dense than aluminum, you can try to get kids to think about the atoms themselves. Maybe it's the copper atoms are smaller, so you can fit more in. Maybe each copper atom is more massive, so even if you got the same number of copper atoms and aluminum atoms, if the copper atoms are more massive, that would make the copper more dense. Or maybe the arrangement is different. Well, it happens that the arrangement is very similar between copper and aluminum.
Copper atoms are larger, so there's not as many of them, but they're much more massive.
So copper is more dense. It has more mass per unit volume. So we use this idea to have kids look at different samples. We have 8 different cubes. They're all the same volume. There's aluminum, brass, copper, steel. This is a plastic, polyvinyl chloride. It's PVC. Nylon is another plastic. And 2 different woods. We've got oak and pine. Students need to determine the density of each one of those in order to identify it. So how do you do that? Well, you need to know the volume, and you need to know the mass. So first, we have a simulation or animation about how do you find the density of a cube. You need to know the mass and the volume. So first, let's look at the volume. So kids will need to measure the height, length, and width of each cube. And they're 2.5 by 2.5 by 2.5 centimeters. And if you do the math, that's 15.625. We round that to 15.6 cubic centimeters is the volume of a cube. What do you need to know next? You need to know the mass. So you can take the cube that we're using as a sample here and take its mass, and it's 78 grams. And then you need to do the math. The density equals mass divided by the volume. So it's 78 grams divided by 15.6 cubic centimeters. The density of this sample cube is 5 grams per cubic centimeter. Now this unit, grams per cubic centimeter, it's going to take some time to explain that to students, but that's the idea of density, is a mass per unit volume, grams per cubic centimeter. On the student activity sheet, students have the volume of the cubes, they write in the mass, and they calculate the density, and then they compare that to the given densities of the substances, and they're able to write in what material is sample A, B, C, and so on. Now students will see that the metals are the most dense, the plastic is second, and wood is the least dense. And even the least dense of the metals, aluminum, is more dense than the plastic or the wood. So why is that? If you look up at the periodic table, the atomic mass of aluminum is pretty high. It's 27. That gives aluminum a pretty high density compared to plastic and wood, because look at the atoms that make up plastic. They're carbon and hydrogen. They have much lower atomic masses than aluminum, and they're not packed as tightly either. And here, wood is very similar to plastic in that it has carbon and hydrogen also, but it also has oxygen, which you'd think might make it a little bit more dense, because oxygen's a little higher in atomic mass, but you know, wood is a living thing. It's got a lot of empty spaces where the cells died. So wood is not as dense as most plastics. If you're in an NGSS state, Performance Expectation MSPS 1-1 says develop models to describe the atomic composition of simple molecules and extended structures. Well, in this case, we're using the concept of density to get into these ideas. So, in fact, you're sort of doing 2 things at once, teaching students an important concept of density, while looking at the molecular level and getting to the idea that you can describe the atomic composition of substances based on their molecules. In fact, if you look at the foundation boxes here, in science and engineering practices, students are developing a model to describe phenomena, in this case to describe density. Also, this idea in disciplinary core ideas that each pure substance has characteristic physical and chemical properties. In this case, we're dealing with the characteristic physical property of density. And on cross-cutting concepts, time, space, and energy phenomena can be observed at various scales. We're just showing that the macroscopic characteristic of density can be analyzed all the way down at the atomic level. Thanks for watching, and good luck with the lesson.